Yeah, great. So, so hi everyone. So from today onwards, we will be starting a new subject. Okay, that will be analog circuit. As everybody is from, I think somebody's from AC and electrical and instrumentation. Okay, so you can also write your branch in the chat box. Okay, so I will be looking at. Okay, so this is about me. I'm Dheeraj. Okay, I have done MTech in VLSI design, and I have been teaching for GATE since more than 7 years. Okay, so I have taught analog circuit and devices, communication, and electromagnetic theory, as well as mathematics and aptitude. Right. So in this class, I will be dealing with the analog circuit. Okay, so, if I talk about today's class, as we are just starting, okay, the subject. So today I will be just discussing about what are the topic I'm going to discuss in further classes, and what are the prerequisite, okay, for preparing this subject, right? And what are the weightage? Basically, if you look back the previous year questions, okay, paper. So, what was the weightage of this subject for respective branch, such as for electronics and communication and electrical engineering and instrumentation? Okay, so this subject basically my plan will be for analog circuit will be, you know, so I will be starting with the very first topic, that will be the op-amp, okay, and the second sub topic will be the diode application, and these topics I have consolidated from the original GATE syllabus, right, and the bipolar junction transistor, okay. These are the original topics, and if you go inside, there will be many topics, right, and then we will discuss the MOSFET, okay. So these are the topics which we will be discussing in our courses, okay. And if I talk about some of the analysis of the previous year gates, right, for electronics, particularly electronics and communication, okay. So if you look at the weightage for this subject, so in 2011 it was asked for 10 marks, okay. So you can see it starts with 10 mark, okay, and in 2012 it was asked for 8 marks, okay. In 13 the weightage got increased, okay. Out of 100 marks, 14 marks was asked for an analog circuit, right. In 14 again 10 mark, okay. So on an average, if you see, so this subject is asked for 10 marks, right. So if you have prepared this subject, so you can easily score 10 marks, right. So you can see till 2011 to 2022 I have done the analysis, okay. So on an average, this subject will be asked for 10 marks, right. So before you get started any subject, you should know the weightage, okay. This motivates you to prepare for, right. And as I discuss, this is analysis for electronics and communications. So if I go for electrical engineering, right? So in electrical engineering, this subject is not asked for many marks, but yeah, in 2011, if you see, only for 6 marks, this, okay. So if you compare the weightage for electronics and electrical, so you will find the very less marks only, right? But 6 marks also makes the huge difference in your rank, okay. But nowadays in 2020-22, they started asking for more marks, right. So you if you see these bar graphs, okay, so I've just done a brief analysis, okay. You can see here in 2020-22, right, this subject was amazing, okay. Like they have asked for many marks, just like ECE, okay. And we will be also looking at what are the topic they have asked, right, where you have to focus, okay. uh, After finishing this entire course, what are the topic you have to practice more for the gate exam, right. Okay, so let's talk about instrumentation branch, okay. So instrumentation branch, more or less the same like electronics and communication, okay. The weightage is good, okay. uh, and analog circuit is very core for electronics and instrumentation, And for electrical it is not that core, but yeah, one should prepare for this subject, okay? So that, because you see the in 2022 it was asked for many marks, right? It's okay. So these are the weightage, okay, analysis of the PYQs, okay. And if I talk about topic wise weightage, right? So majorly, what are the topic we have to focus, right? And but though we will study all the topics in detail, okay. But if you see this pie chart, so I have just done analysis based on pie chart. So OPAMP has a huge percentage. You see, 47 percentage. Only I have taken couple of year paper. So it is the 2022 paper last year only in electronics and communication. So you see, only two topic were asked, right? You see, having great percentage, OPAMP at the MOSFET and the diode here. Okay, diode was asked for 13%. Okay, and this is 47%, and MOSFET, right? You see here the bipolar junction transistor is not asked for any marks, right? So from past 5 year, 5 to 6 years, this bipolar junction transistor is not being asked. Only people are focusing, all the IITs are focusing on MOSFET and the OPAMP and the diode, right? But we have to study everything, okay? This year also, like in 2013, I don't think so they will be focusing on bipolar junction transistor, right? So this was all about 2020, and if I talk about 2021, right? So again, you see diode has 17% and BJT has again zero, right? So yeah. Okay. So you see here, OPAMP has again got 58%. Means OPAMP is one of the very important topic. Okay, that's what we will be starting with, right? And the MOSFET is very very important. Okay, compared to BJT, and I will discuss the reason as well why MOSFET is very important. So more or less it was similar. And in 2022, if you talk about electrical engineering, so diode and so in electrical engineering, diode has good weightage. Okay, VJT 0%. You see, the MOSFET nowadays has been started. They started asking MOSFET as well in electrical engineering, right? So OPAMP has good weightage for electrical engineering. Okay, so only three topics you see: diode, OPAMP, and MOSFET. Okay, in 2020-21, diode you see 50%, right? And the BJT was also asked. Okay, so we can't ignore BJT, right, for electrical engineering. Though these topic has good application in other core subject of electrical engineering, right? OPAMP you see always has favorable percentages, right? And if I talk about instrumentation brands, so yeah, in instrumentation, I think event distribution is there. Okay, for you see, okay, diode, BJT, MOSFET, okay, and the OPAMPs. OPAMP. So we will starting. We will be starting with OPAMP. It is very very important topic. And in 2021, you see, this was the so VJT, MOSFET, OPAMP, right? So this is what the analysis is, the basic analysis, right? So 1 minute, yeah. So I believe this is yes. So these were the things in 2021, right? Now we will be starting with the prerequisite. Okay, before you start any subjects, okay, what are the prerequisites you must be having before you get started any subject? So for this subject, basically, we must be familiar with the basic electrical, okay, concept, basic electrical engineering concept, right? So in fact, I will also brief them because you haven't started this network theory. Okay, so we call this as network theory, right? Okay, so though you need not to know many things, I will just list down what are the important topics are there, right? So one must be good at KVL, okay, these laws, KVL, KCL, okay, Ohm's laws, right? And basic theorems, right? Basic network theorems, okay. These are the prerequisite for analog circuit. basic theorems. Okay, and AC and DC circuits. Okay, AC and DC circuits. Okay. So, though I will just give you the review, okay, before I start any topic of analog circuit, I will talk about the basic elements. Okay, the basic elements are like R, L, C, right? These are the basic electrical elements, and we will also talk about active elements, okay, such as voltage source, current source, right? So these are the enough. These are the enough prerequisite, okay, and one more subject is there, that is devices, okay, electronic devices, right? Though you need not to know about devices, only you need to understand the symbol of them, right? So all the symbol you should be familiar with symbol, right? Okay, so if I talk about any symbol, such as if I ask you what is this, right? What is this? If I talk about three terminal device, right? So we can take 1 minute. Yeah. So this is two terminal device, right? And if I talk about three terminal device, okay. So this is the three terminal device which is known as BJT. And if I talk about again one more three terminal device, that is MOSFET, right? So if you know these symbols, if you're familiar with these symbol, this is enough, right? Because in analog circuit, what we will do basically is we'll apply some voltage around them, okay, and we will see the current, right? We will see the current. We are not interested what's happening inside these devices, right? We will again apply some of the voltage here depending upon their terminals, right? Okay, VCE and some of the voltages, and we will see what are the current flowing through these terminals, right? That's it. Okay, again we will apply some of the voltages, okay, because in BJT this will be the a base, collector, and emitter. In this case, this is gate, drain, and source. So I will discuss all of them. Okay. So you need not to know what's happening inside the devices. Okay. These symbols, right? Only you should know if you apply this voltage, what is going to be the current. So we will talk about the IV characteristic, right? IV characteristic for this two-terminal device, which is called, uh, you know, diode. And this is again we will talk about here the IV characteristic. We call it output IV characteristics, right? I versus V, right? And here also we will talk about IV characteristics, right? I versus V. So we are just interested to know about the terminal characteristic of electronic devices, right? So if you don't know, if you're not familiar with the physics behind diode, physics behind BJT, bipolar junction transistor, so still you can understand entire analog circuit, right? So I believe these are the prerequisites you have to, okay. And one more thing I would like to tell here is that uh, you should be very very good at circuit, right? The basic circuits, okay. So if I ask you that what is the basic element in the electrical engineering, right? So they are just resistor, okay, and capacitor, okay, and the inductor, right? These are the three elements which are known also as passive element, right? They are the passive element, okay. You will come to know what is the meaning of passive and all, but you should be familiar with these three elements, R, L, and C. Again, as I discussed, that you don't have to worry about the physical parameter of them. Just you should know if you apply the voltage across the resistor. So as it is a two terminal device, so you should know there will be a current, right? So this will follow the Ohm's law, and Ohm's law, we know that V equal to IR, right? So this is simple, law which one must know, okay, from the, I think from high school, okay. And if you apply the voltage across the capacitor, so there will be a current again, IC, okay. And if you apply the voltage across the inductor, so there will be a current IL, okay. So if you know the basic relationship between voltage and current, okay, for these elements, right? For these elements such as resistor, capacitor, and inductor, so that is enough, right? So in case of resistor, if I talk about the basic relationship, so you see the basic relationship is what? V equal to IR. And in case of you know inductor and capacitance, as they are also known as memory element. They are also known as memory element, right? So they will be storing charges, okay, like capacitor will store electric charge, okay. So one must know the relationship between current and voltage for capacitance also, okay. So let me take the capacitance here, okay. Just I'm giving you the recap of these basic circuit elements, because you will go through all these things in network theory, right? So if you apply the VC and you will find the current I, okay. So how capacitor charges, you should know that the relationship between capacitor and the voltage, that is IC, will be equal to C dV by dt, okay. dVc by dt means rate of change, right? Rate of change. So this is the basic relationship between capacitor and capacitor current and the voltage. And you can also determine the voltage across the capacitor. That is going to be uh, if it is differentiation, okay. So it will be integration, okay, from 1 by c integration minus infinity to t I tau d tau, right? So this is what the basic relationship between voltage and current. And if I talk about inductor, right? So inductor means this is the inductor, twisted wire here. And if you apply the voltage here, VL, okay, T, and there is a current IRT, you can say it is a function of time. So you can write so it will be the VL equal to L di by dt. Okay? And you can also determine the current I will be equal to 1 by L minus infinity to T V T dt, right? Like this. Okay, so these are the basic relationship between current and voltage. One must know. Okay, so these are the three elements. Okay, they are known as passive element, right? And these are the elements. Okay, what we have discussed here, like two-terminal device, that is diode. Okay, they will be discussed in detail. Okay, so these are the element which is known as active, okay, elements, right? They are the active element, and these are passive elements, right? And we will also talk about some of the basic active elements in the network theory. Active element, they will be the voltage, they will be sources, right? We can say voltage source and voltage source and the current source, right? Because you know that in electrical engineering there are two uh, quantity, that is current and the voltage, okay. And if you combine them, you will get power. So these are the three things, okay, we always discuss in electrical engineering: the current, the voltage, and the power, right? If you know the relationship between current and voltage and power, so everything is easy, right? One, okay, any circuit they will give, and they will ask what is current through any branch, okay, what is the voltage across, okay. So for current we always use through, okay, current through, okay, and we always take across, right? So we use different we use a meter to measure the current, and we use voltmeter to measure the voltage, right? So voltage source will be there will be two kind of voltage sources. One will be independent voltage source, right? Independent. And one will be dependent voltage sources. So I think you guys are familiar with these things, okay? So you can write, and this is again independent and dependent, right? So we will, yeah. So we'll talk them in detail as well, right? So these are the active elements: voltage source, current source, right? And only you need to understand the symbol of them, right? So if I draw the symbol here, so the symbol is gonna be for voltage source. Simply you put one independent sources here. So you put one circle plus minus, okay? So this is the voltage, okay, independent voltage source. And there is some property, right? Okay, you need to know the I versus V characteristics, right? So suppose this is independent voltage source, which is ideal, okay, is ideal voltage independent source, voltage independent source, right? Okay, so you can see here, guys, if you apply, okay, you see here, this is voltage, right? So if there will be a current I, you can say, right? So there is only voltage source, right? So if you draw the IV characteristic for this, right, I versus V, okay. So here you see this voltage is constant, okay. This voltage is constant, and whatever current is flowing, this voltage will be always constant, right? This voltage will not change, right? You have to understand this, okay. So whatever current you will be flowing through this voltage, it will be always constant, right? So suppose voltage is this, right? You see the voltage. Suppose voltage is any voltage. You can say 5 volt is there. So ideal voltage source has this property that whatever current is flowing, it is not going to change this voltage. Okay. So the terminal voltage is gonna be same. Terminal voltage will be always same, right? Will be always same. Right? So this is IV characteristic. You see there is a line, okay, which is parallel to current, or you can say bi-axis, okay, and this voltage we have kept here. If you draw, if you keep voltage here and the current here, so this will be like this, okay. You see here, okay, this is how we can draw the IV characteristic, and this is also the VI characteristic. Okay, both are same. Okay. So here you see you are changing the current. Okay, you are changing the current, but voltage is what, constant, right? Okay, so you can also find the slope of this, right? If you find the slope of this VI, so you know what is slope? Slope is basically the change in y upon change in x, or you can say change in voltage upon change in current, right? So what is change in voltage? There is no change in voltage, right? And there is a change in current, so you can say anything, right? So you can say that the slope is going to be what, zero, okay. So what is the meaning of slope? What is V by I? As we know the Ohm's law, okay, V by I means resistance, okay. So this is the value of resistance basically, okay, resistance. So if somebody will ask you that what is the internal resistance of ideal voltage source, so you can say zero, sir. Okay, you can say zero, sir, because you can determine from this from this vi characteristic, this slope, right? Or you can determine the slope of this, okay. So IV characteristic, if you find the slope, so del y by del x, which is change in current, like change in current upon change in voltage, that is zero, which is infinity, right? The slope here is infinity, but I by v is not the resistance, okay. I by v is basically the conductance, right? Okay, so you should know all these things, right? We know that V equal to IR, right? So V by I is basically the R. And if you take the reciprocal of this, so I by V is going to be conductance, right? Okay. So these are the things which you should know. So if suppose IV characteristic will be given, right? Suppose this is I versus V characteristic, and somebody will ask you what is the resistance of this. Can you find the resistance? Yes, we can find. How? You just take the slope, find the slope. Okay. So slope is gonna be change in I upon change in V. Okay, which is going to be resistance. Sorry, which is going to be the slope, right? And if you take the reciprocal of this, okay, if you take the reciprocal of slope, 1 by slope, right, which is going to be the resistance, okay. Okay, so most of the time you have to habituate yourself with these IV characteristic, right? Because these picture can help you determine anything easily, and you don't have to dependent on formulas, right? So this is basically the conductance, right? And as I told you that the conductance, okay, Conductance is the reciprocal of resistance. Okay, so this is the characteristic of ideal voltage source. Okay, so ideal voltage source has internal resistance, you can say zero. Okay, and in future you will find that suppose you have to replace this ideal voltage source, right? So you will replace this ideal voltage source. Okay, so if you will replace this ideal voltage source with the in the circuit, right? So you can replace it by short circuit, right? Okay, what is the meaning of short circuit? Okay, so this voltage source can be replaced by short circuit. It means we are replacing this voltage source by you can say internal resistance. Okay, and suppose there is a current source, right? Suppose this is a current source. Okay, ideal current source I'm talking about. One circle is there and this is the current. Okay, we call it I. Okay, and the current has the basic unit is ampere, right? And you apply anything, any voltage apply across this current source, okay, which is ideal, right? Which is ideal. So this current source will not allow to change its terminal current, right? This current is going to be always same. So if you draw the IV characteristic for this again, I versus V, and naturally you can draw. Okay, so you are changing this voltage. Okay, you are changing this voltage, but this current is going to be same always. You see, this current cannot change, right? This current cannot change. So you can again determine the resistance for this, right? You can again determine. So what is the resistance? First of all, you need to find the slope, and the inverse of the slope, or you can say reciprocal of the slope, is going to be giving you the resistance, right? So change in I upon change in V, right? So change in I is zero and change in V is anything, right? So you can determine easily the it is zero, right? The slope here is zero. In fact, by looking at this IV characteristic, you can understand the slope, right? Which is zero. Okay, and suppose there is a vertical line. If there is a vertical line, means the slope is infinite. If this is the this line is parallel to x-axis, means the slope is zero. And if you take the ratio of reciprocal of that, so that will give you the 1 by slope, right? Means infinity. So if somebody will ask you that what is the internal resistance for current source, right? Ideal current source. This is ideal current source, right? Remember, ideal current source, right? Ideal current source, practical current source, ideal voltage source, practical voltage source, right? We will discuss all these things. So here you see resistance is infinite, right? So suppose in future circuits, right? If you will replace this current source, right? This is a current source, and if you want to replace it by, or what is the equivalent of this current source? Okay, so how can you make this current zero, right? How can you make this current zero, right? So you can replace it by open circuit, right? So what is the meaning of open circuit? What is the meaning of short circuit? We will see now, right? So this is how you have to remember these things. So what is the meaning of short circuit? Short circuit, right? Suppose any network you see, any circuit connection you see, and we call simply this is the short circuit, right? This is the short circuit. We call it short circuit. Short circuit means the voltage here is zero, the voltage here is zero, and the current will be there, right? The voltage across this, you can say this is A and this is B. The voltage will be zero, and if voltage is zero, means resistance will be zero, right? And there will be only current, right? So if you take the change, right? If you find the change, right? Suppose resistance is what? Change in voltage, right? Upon change in current. So change in voltage is zero and change in current is anything, right? Anything means huge current can flow through the short circuit, right? So short circuit just meaning here is huge current is flowing, okay, and there is simple wire and wire having zero resistance. You can say, okay, this is the short circuit. And if I talk about open circuit, okay, so these are the extreme conditions, okay, open circuit. So any circuit if you see, okay, and there is open like this, A and B, right? So here you can say there can be anything, any voltage you can apply here, but the current will be always zero because there will be infinite resistance. And we know that what is resistance? Resistance is basically a property of any material which oppose the current, right? So if there is an open circuit, the current will be zero, right? The current will be zero. So, or you can also mathematically check. Resistance is basically what? Change in voltage upon change in current, right? So here change in voltage is anything, right? Anything, but the current is zero. You can say it is going to be infinity, right? So open circuit meaning here is the resistance is infinite and the current is zero, and the voltage can be anything, right? You can measure the voltage, okay, and it can be anything, right? I believe this is fine for everybody. uh, yeah. So guys, yeah. So these are the open circuit and short circuit concept, right? And okay, so that was ideal voltage source and ideal current source, okay. And if I talk about practical voltage source, okay, practical voltage source, practical voltage source is what? So practical voltage source is nothing but a voltage source, right? This is just a symbol you have to know. As I told you that couple of things you have to take care: symbol and the IV characteristic, right? The I versus V. Okay, like if you put you can put the current on the y-axis and you can put the voltage on x-axis. So this is ideal practical voltage source. If there is a practical voltage source, so definitely there will be one resistance which will be in series, right? So there will be R and this is voltage, okay. So you see here now, this is a finite resistance which we are keeping in the series, okay, with the voltage source, okay, okay. And so now what you can do here is, now there will be a current, right? Now there will, suppose you connect some voltage here, I mean some element here, right? So yeah. So if you connect anything here, right? So now this circuit, this is known as circuit. Why? Because there is a closed path. Okay. So in fact, I did not talk about circuit, right? I started discussing these elements. So what is the meaning of circuit basically? You should know, right? So as you can see here, these are the element, right? The voltage and the resistance, okay? And I have connected one more element which is electrical element. It can be anything. It can be the resistance, capacitance, or anything, right? Inductance, right? So now what will happen here is that if you try to find the current here, right? If you try to find the current, uh, and if you try to find the voltage across this, right? So what will happen here is that if this is a voltage and there will be some drop across this resistance, that will be I times R, right? Because the current is flowing through this resistance, that is I times R. Now this voltage, you can say load voltage or VL, and this is the source voltage, you can say, right? So if you apply the KVL, right, the KVL, right, that is Kirchhoff's voltage law, okay, Kirchhoff's voltage law, and there will be Kirchhoff's current law, right? So if you apply the KVL, right, so you can apply the KVL, like we will start with first sign, so minus VS, and this is the first, okay, that is plus IR, right? And this is first sign again we have to take, that is VL equal to 0, so that you will not make any mistake. So in KVL, while applying KVL, you either start with first sign or start with second sign, right? While writing the KVL, okay. So KVL is nothing but the sum of all the voltage drop, okay, around the loop, right? Sum of all the voltage drop, right? Voltage drop around the loop should be equal to 0, right? So from here you can see, you can find the VL. VL is going to be VS minus IR, right? Earlier, you see, earlier when this resistance was not present, right? This resistance was not present, so this voltage was not changing, right? But now you see here, this voltage is changing, okay? So the overall voltage is gonna be Vs minus IR. So if you draw the picture, okay, V versus I, right? V versus I. Because of this current, right? Initially, it was like this. Okay, this was ideal picture, right? Vs. But now there will be a slope. There will be this kind of a, okay, negative slope is there, right? Means there is a change in voltage, you can say. There is a change in voltage, okay? So this is the practical voltage source, okay? This is a practical voltage source where the series resistance will be present with the with the voltage, okay? So it is still, you can say, ideal voltage source only, but if you connect in series with this voltage source one resistance, so it becomes practical, okay? So this is the IV, okay? You see here, as you increase the current, if you increase the current here, this voltage will go down, right? Okay, so what is the change here? You see here. Now, if you find the slope of this, right? If you find change in voltage upon change in current, basically change in voltage is this, right? And change in current also you can find. Okay, so change in current is used, right? So that will give you the resistance. Okay, so this is the practical voltage source. And if I talk about practical current source, practical current source, right? The practical current source is nothing but, there will be a current, right? Current source I, okay. And as we discuss, ideal current source always maintains its terminal current, right? No matter whatever voltage you apply, this current will be always constant, right? Or same. And if somebody will give you this kind of a picture, right? I versus V, so you can directly tell that, yeah, this is ideal current source IV characteristic, right? Because the current is constant and the voltage is changing, right? So you should be able to make wonderful observation, right? And now what we will do here is, in case of practical current source, always keep in mind there will be one finite resistance which will be connected across this current source. Okay, understood. Now you can connect any load, right? Any load you can connect. Okay, and there will be also some current IL. Okay, and there is some current also, right? So if you apply some voltage here, right, V, okay, so this V will be, because they are connected in parallel, right? So in network theory, you will study about series and parallel. Okay, so this is what the parallel is. Why we are calling these elements are connected in parallel? Because they are at same potential. You see, this is, these three elements are at same potential here. Okay, if you see, this is V, this is V, this is V. Okay, okay, that's why they are the parallel. Okay, they are connected in parallel. So if voltage across this current is V, the voltage across this will be V, the voltage across this element will be V, right? So you can determine the IL here, right? Earlier IL was equal to I. Suppose this R is infinite, okay? If R is infinite, then what you can say? If R is infinite, okay, so you can say that this I will be equal to IL, means, let me draw this picture separately here. This is I and this is V, right? So ideally this is the picture, right? Ideally, okay. But now, as this R, which is finite, okay, this R is finite. Why R is finite? Because there is a slope, okay, which is finite, you can say, right? Or so you can say here, if the slope is finite, definitely you will get finite resistance, right? So this is the ideal picture, but now the current will be decreasing, right? The current will be decreasing here, okay, right? So you can apply the KVL at this point, right? What is KCL? You can apply KCL, right? Because this is a node, okay? So some of the basic concepts are there, okay, which you will go through in network theory, such as node, voltage, node, mesh, all these things, right? So you can apply the node here, okay? I mean KCL there. What is KCL, right? KCL means Kirchhoff's voltage law, right? Sorry, Kirchhoff's current law, not voltage law, right? Kirchhoff's current law. Okay. Suppose you have got any node here, node, okay, node where many branches are connected. You can say one branch, one more branch, one more branch. Okay. This is the KCL, right? Kirchhoff's current law. And you know the branch current like I1, I2, okay. I3, I4, I5, and I6. You can say also this is a junction kind of a thing, right? Where many branches are meeting. So now you can apply the KCL. So KCL is nothing but, okay, uh, suppose these currents are coming to the node, right? These current are coming to the node. So you can say that sum of incoming current, right, equal to sum of outgoing current, right? This is the KCL, right? So what you can do here is whatever currents are incoming, right? So you can add them. So I1 plus I2, okay, plus I3, okay, and which is equal to whatever currents are going away from this node. So you can say I4, I5, and I6. Right? So this is basically the Kirchhoff's current law. Okay, and if you write the current in terms of voltage and resistances, suppose you're writing this current like V by R1, right, plus V by R2, okay, plus V by R3, right. Suppose they are connected in parallel, all resistances are connected in parallel like this, okay, okay. These resistances are connected in parallel, okay, like this, okay, and the voltages are same, okay, in parallel, always keep in mind. So we are writing V by R1, V by R2, V by R3 equal to V by R4 plus V by R5 plus V by R6, right? So after writing KCL, okay, you're writing current in terms of voltage and resistance, right? So this is known as nodal analysis. This is known as nodal analysis, right? So how you're writing V by R, you know that the basic Ohm's law, right? So always keep in mind the KCL plus Ohm's law will be equal to nodal analysis. Okay. Nodal analysis. What is the meaning of analysis? Right? That is also one of the very good question one must know. So let me ask question here to you all, right? So tell me what is the meaning of nodal analysis? Yes, guys. There is 1 minute. Hmm, yeah. Yes, guys. So we will discuss what is the meaning of analysis. So you see, guys, in the basic, okay, the meaning of analysis is basically see the circuit will be given, right? The circuit, okay, will be given, and the input will be given, right? Input will be given, and if you have to evaluate the output, right? Output. So these two parameters will be given, right? And you have to evaluate output, right? So this kind of questions are asked in the gate examination, the analysis based question, right? They will give you some voltage source, okay, to energize the circuit, right? And they will give you the circuit and they will ask what is the output, okay. So output can be current through the branch, output can be voltage across the branch, right? So this you have to keep in mind, right? This is the process of analysis, right? What is the meaning of this process of analysis, right? If somebody will ask you what is the meaning of analysis, in fact, you will come to know the network analysis, right? So analysis meaning is nothing but the input and circuits, or you can say some system will be given. Okay, sometimes we call it system also. You will study one subject called signal and system. We will talk about in fact we will be talking about analog circuit, right? So circuit, analog circuit, right? So input will be given, any circuit will be given, you have to find some output, right? And one more concept is there, that is known as synthesis. Synthesis, okay. What is the meaning of synthesis? Synthesis meaning here is the input will be given, okay, and the output will be given, right? And you have to build the circuit, right? So these two parameters will be given, okay. So though in the gate examination, they don't ask these kind of a question like input is given, output is given, you have to build the circuit. But when you go to industries, right, so they will give input, okay, they will give output, okay, so you have to achieve this target, you have to achieve this desired result, so please build the circuit, right? So this is okay, done in the companies which you join after pursuing MTech. So this is what you have to build, right? So this is the process of synthesis, or you can say design, right? Okay. So I believe now you understood what is the meaning of analysis and synthesis. Okay. So nodal analysis meaning here is nodal analysis is nothing but the KCL and the Ohm's law. Okay. And the KVL, if you apply KVL and if you write, okay, if you express that voltage in terms of current and resistance, so if you if you use the Ohm's law, that is going to give you the, you can say, the mesh analysis, right? Mesh analysis, okay. Certainly, you will be having you might be familiar with what is loop, what is mesh, okay, what is all these things, but I can also give you in in summary. So as we know that suppose we have got these elements, right, these elements, they can be anything. Just I'm drawing them in the form of black box, right? So suppose this is A, this is B, and this is C, this is D, okay. So you can see here, if you go, okay, if you start from this point, right, and if you go across this, around these elements which are connected, right, so you go from here to here to here, right, again you reach here, right. So this is basically a mess, right? This is a mess, okay, you call it, or sometimes we call it loop as well, right? So when you interconnect the elements, electrical elements in such manner, right, in closed path, okay, it is forming a closed path, okay. So closed path. So mesh is basically a closed path in the circuit, right? Closed path in the circuit. You have to remember always, okay. So you will find two words. One will be the circuit, okay, and one will be the network. So what is the meaning of circuit and what is the meaning of network, that you have to understand, right? So circuit is basically which will be having the closed path, right? Suppose I draw this kind of a these kind of interconnection of all the elements, right? So these are the elements, you see here, these are the element I have connected here, right? So if somebody will ask you that is it a circuit or a network, right? So you have to always understand circuit means closed path, okay. But network can have, you can say, may or may not have closed path, right? May or may not have closed path, right? So this is very very important to understand. So circuit means, if I talk about, this is what the interconnection of all the elements, right? We have connected all the elements here, okay. So there is a closed path, right? But there is no closed path, there is no closed path, right? No closed path. So this part of the this part of the network, you can say, this entire, okay, whatever connection we have seen, this is basically forming a circuit, right? But this is a network, right? This part is the network, okay. This is the network. So you can see here, network can have closed path, okay, and the circuit should have closed path, remember, okay. So for circuit to define, there should be a closed path, right? So this is the basic difference between network and the circuit. So sometimes network theory is called as circuit theory as well, right? So these two words are like you can use interchangeably, right? And as I discussed that mesh and the loop, okay, the mesh and the loop, right? There are two words, okay. These are also to be understood because many students get confused here, right? So suppose we connect, so whatever we are discussing now is the prerequisite, okay, for analog circuit. Though these things will be taught in detail in network theory, right? Yeah. So you see here, as I told you that if there is a closed path, okay, if there is a closed path, suppose I just put here one short circuit, right? So you see here, this is one mesh, okay. You see from A to B, from C, D, this is E and this is F, right? So you can say A, B, C, D forming one mesh, right? And there is again one mesh. So there is one mesh, there is second mesh, right? Okay. So these are the two meshes. Okay, these are the two meshes. So we can say that mesh is basically a closed path present in the circuit. Okay, but how many loops? Okay, in the question they sometimes ask is how many loops are there? How many, how many meshes are there? Right. So one should be able to know that, right? Not in analog circuit, nobody is going to ask you, but in case of in network theory they ask, right? So there is a one, so here two meshes are there, right? Two meshes. Okay, but if I ask how many loops are there, so if they are the meshes, so you can say there are two loops. Okay, because there are two meshes, right? But one, you can also go around this also, right? Okay, you see, if you know the voltage across them, right? Suppose V1 is there, right? Voltage across this is V2, voltage across this is V3, okay? Voltage across this is V4, V5, right? If you know the voltage across them, so you can apply, so there will be one more loop, right? So there are three loops basically, okay? So you can say these meshes are basically the individual loops, right? But this big loop, okay, this loop contains these individual loops as well, right? So you can't say the big loop is a mess, right? Okay, so you can say here the mesh can be the loop, okay, but loop may or may not be the mesh. Okay, remember always. Okay, so in the loop there can be the mesh, okay, but in case of mesh, okay, there should not be any internal closed path, right? Suppose I draw one more circuit. Suppose this is a circuit, right? So I can say this is a mesh, right? I I can say this is a mess, but suppose I draw something here, right? Okay, so now this is not the mess, not the mess. Okay, okay, remember. So this will be the mess. Okay, this is not the mess. Okay, this will be the loop. Okay, so you have to keep this in mind. So mesh analysis, loop analysis, sometimes we call. Okay, so mesh analysis means what? Mesh analysis means the KVL plus Ohm's law. That is mesh analysis. Okay? These things you have to remember. And yeah, yeah. Now, if I talk about how many meshes are there, suppose I give you any circuit, right? So if I give this is the circuit here, right? And you have to determine how many meshes are there, right? Just I'm drawing one circuit where the black box element is connected, right? And you somebody is asking how many meshes are there. Okay, so how can you find the mesh, right? So you see here there is a formula to calculate m number of meshes, which is given as minus b and plus 1, right? So this formula, if you know, you can quickly determine the number of meshes. Okay, what is b here? B is basically the number of branches, okay, number of branches present in the circuit. Okay, you have to keep this in mind, right? 1 minute. Yeah, so number of branches, and n is the number of nodes, right? Number of nodes. Okay, so you can determine here the number of meshes now. So can somebody tell me how many branches are there? So you see one branch. What is the branch basically? Remember, the branches are basically the element itself. Okay, element itself is a branch. Element itself is a branch, you can say. Element itself is a branch, right? So there are how many elements you see? One element, two element, three element, four, five. There are five branches, right? You can't say this is a branch, right? This is not a branch because there is no element connected, right? Okay. So if you want to decide, if you want to connect one element, you need at least two node, right? See, one node is this, one node is this, right? So this is basically one element, right? So element itself is a branch. So how many branches are there if you can count? One, two, three, four, five, right? This is not a branch. Remember, this is not a branch, okay? Because there is no element connected. So we can say that B equal to five, okay? And how many nodes are there? If somebody will ask. So there is one node, okay? Because there are two elements which are connected. There is one node again, okay? So there are three elements, okay? This is again one node, right? And there is one node again, right? You see here, this is one node only, okay? You can say the bottom node is one, right? Because the potential here is same for all. So node is, how many nodes are there? One, two, three, and four. So there are four nodes. Now you can compute the M. And though by default you can directly answer the question here, how many one mesh and one mesh? There are two meshes are there, right? Only two mesh. But you can compute using the formula as well. So this is 5 minus 4 plus 1, right? So 5 plus 1 is 6 minus 4, which is 2. Yeah. Okay, so please keep in mind what is mesh, what is branch, what is node, what is loop. Okay, so if somebody will ask how many loops are there, so you can say there are three loops, right? But there are two meshes, and we always apply, we always apply KVL, okay, plus Ohm's law, right? While calculating, suppose you want to find the current in this loop or mesh in this loop, suppose I1 and I2. So we will apply. So you will get two equations, right? And you can solve them. Okay. So loop can so KVL can be applied anywhere, right? KVL can be applied anywhere. Suppose this kind of a circuit is given. Okay, because you will find. Suppose I just take one circuit, simple circuit I am taking. Right? So this kind of a circuit is given, and you will not find anything here, right? No loops, nothing is there, but still you can find. Suppose this is E, right? You have to determine E, and this is 10 volt, okay, and this is 5 volt, okay, and this. So here you have to calculate. Suppose this is V1 and this is V2. So somebody will ask you, can somebody tell me what is the relation between this V1 and V2, right? So remember always that suppose this is V1, right? Some voltage is connected here and written here as a V1. So you have to always consider it like a voltage source, right? That is V1, right? Like this, okay? In the analog circuit also, I will draw the BJT like this, right? Suppose I'm drawing the BJT and I will write plus VCC. VCC meaning here is there is a voltage source, right? That is VCC, right? So whenever you will write case KVL, okay, you will not get confused, right? You will not get confusion, right? And in fact, you will not make mistake in the polarity, okay? So this is what the potential here connected like this. That is, you can say V1. Now, and this is again one, okay, this is V2. So you can apply one, KVL from there to here. Now there is, we consider that there is a closed loop. How? Because there is a node. Okay, these two grounds are at the same potential. So we are forming one closed loop only. Okay, we have to consider by observation. You can't see, but yeah. Now you can apply the KVL. I have told you very easy method. Okay, because these voltages are known. You can say here we can't apply KVL because we don't know the voltage here, right? Until somebody will specify. So you can apply here. So as I told you, first sign minus V1 plus 10, right? And this is again plus, okay, right? So this is E plus 5, okay, plus V2 equal to 0. So you can take variable one side and everything, right? So if E is known, suppose E is 10, right? So you can take 10, okay, so E is 10, right? So V1 minus V2 equal to 10 plus 10 plus 5, right? So that is 25, you can say. Okay. So this is the relation. Okay. And if you know V2, you can find V1. So this is how one can apply the KVL, right? We will be applying in BJT, MOSFET, and everywhere. Though I will give you the technique where you can avoid KVL also, but for not to make any kind of mistake, we have to apply KVL correctly and KCL correctly, right? Okay. So I believe this is fine for everybody. Huh? Suppose I will write like this. Suppose I will connect. Let me erase this. Okay. So here you see, suppose I connect to one resistance, and resistance is having the value 5 kilo ohm, right? And we know the voltage, that is 8V1 and 7V, okay, we call it. So suppose you have to find the current, okay, directly, right? So you can directly apply what? You can directly write this current, right? How can you write? You can apply, 8 minus 7 upon 5k, right? So just take the potential difference across this. What is the potential difference? That is 8 minus 7. Okay. But sometimes many students make mistake. Okay, they don't understand. Okay, you can write this as by inspection, right? 8 minus 7 is basically 1 by 5k, which is if you take kilo up, right? So kilo up means milli, right? You can say milli. Okay, so it is very simple, 1 by 5 milliamps, right? So 1 by 5 also you can write like 0. 2. Okay. So but suppose somebody is not comfortable writing finding current like this by inspection, so you can just say that this is voltage source, right? This is 8 volt, and this is 7 volt, and this is 5k, right? So if somebody is not smart, right, so a beginner can use this, but till your preparation becomes okay, you should use direct, right, by inspection. So now you can apply, and you can say that there is a current I, so we have to find I. Now you can apply KVL, right? So by KVL, so you can skip these steps, whatever steps we are writing. So minus 8 plus 5k times I, because KVL means collecting voltage drop around the loop, and this is 7 equal to 0. So now you can further manipulate, because this is the equation in one variable, right? So only one current which is unknown. So this is 8 minus 7 by 5k, which is again 1 by 5 million. So how many steps are there? Okay. So you see, we can avoid these steps. Okay, what step we have written. Okay, so you can escape. So in the gate examination, if you are good at making observations, so you can write. So this is by inspection, and this is by making extension. Okay. So these things you have to understand, and there are few theorems also, okay, which is named as Thevenin theorem, right? Theorem. Okay, so the very first theorem which is important for the gate examination is, for analog circuit, particularly to solve any problem very quickly, is the Thevenin theorem. Okay, Thevenin's theorem. Okay. Uh, so Thevenin theorem will be nothing but, suppose you have got one black box, okay, which is network. Okay, black box, why I'm saying is because there can be many elements which are connected here, right? Voltage source, current source, resistance, okay, all kinds of element, right? So the voltage source will be there, the inductance, current, whatever, right? And there will be one load, right? You can say there is a load, and you have to find the current IL, okay, and there is a load. Okay, so somebody will ask you that what is the IL? If there is a network will be given and load will be given, and they will ask what is the current through this load, right? So you can apply the Thevenin theorem here, right? So what you can do here is that you can consider Thevenin theorem says, that this entire network you should see like a single voltage source, that is known as VTH or Thevenin voltage, and one resistance, that is RTH, and there is again you connect RL here, okay, and you can determine IL, right? So entire network, which is black box, okay, you don't know about this network, can be considered like a VTH and RTH, okay? So how to calculate VTH and RTH? That is the next question, okay? So you can convert this entire network, a big network, okay, by looking from here, okay, by looking from here, right? Okay, if you're looking from this side, okay, so this entire network should be seen by you, okay, like VTH, okay, and the RTH, okay, and then you can connect back this RL and find out. So how to find VTS and RTS? That is the main question. So VTS can be found out with the help of open circuit, right? So VOC, or you can say VTH. We call VTH as open circuit voltage. So what you have to do here is, suppose there is a network, okay, so you have to remove this load, okay, by open circuit, right? And you write here VOC, okay, and use KVL, KCL, and Ohm's law, right? And you can determine this VOC, right? Okay. So for this, you have to open the load. Okay, that is very simple. And how to find RTH? So to determine RTH is very simple. Okay, it depends upon just like we try to find the equivalent resistance. Okay, so this is just the equivalent resistance, right? To find out, okay, so again you have to remove this load, okay, so it will depend upon the various it will depend upon the network, okay. If network contains only independent sources, there are no dependent sources, okay, so this is one of the method. You have to remove the VTH, okay, I mean you have to remove this remove RL. Okay, that is first, and second is replace. Okay, replace independent voltage sources. Okay, independent voltage source. Okay, by its internal resistance, that is short circuit, and independent current sources by open circuit, right? And then you can apply the series parallel combination and you can determine RTH, right? So we will discuss all those things, right? How to do all this. But I believe now Thevenin theorem is okay. Is like I have introduced here. So we will discuss all of them. And one more thing you have to be good at is the voltage division rule and the current division rule. Voltage division rule and the current division rule, okay. What is voltage division rule? Where voltage will be divided, okay. So suppose we connect two resistances which are connected in series, right? Why we are calling it series? Because they are because the current will be flowing through them is same, right? And if you connect one voltage source here, that is V, right? So if somebody will ask you what is the voltage across this, so you will call it V1 and V2, right? So always keep in mind that voltage division rule is applied when elements are connected in series, right? In series. And current division is applied when elements are connected in parallel, right? So parallel meaning the potential will be same, right? This is what the meaning of parallel, right? So here you see, suppose there is a current source, right? I, and there is this is R1 and this is R2. So two resistances are connected in parallel. It means the potential across them is same, right? But the current will be different, I1 and I2, right? So you can find V1, okay? You can find V1. How you can find V1? You can apply the KVL, okay, and you can find, or you can by inspection, you can write here V1. What is V1 here? The total voltage, that is V, right, into the voltage which you are finding across the element, you have to write first, that is R1, and sum of the resistance, that is R1 plus R2. This is how you can find V1 by inspection, or you can apply the KVL and then replace this I. Okay, okay. that is very simple. Okay. And like you can find I, so I will be V by R1 plus R2, and then V1 equal to I times R1, right? Like that you can do. But okay. And V2 will be what? Total voltage V1, sorry, total voltage V, and the voltage you are finding across R2, and this is sum of the resistance R1, R2, right? So you can connect n number of resistances in series, and you can determine the voltage across all the elements. Here you can see, first step is you can apply here the KCL, that is I equal to I1 plus I2, because the incoming current is I and all outgoing currents are there, right? So now you can write here. Okay, so now you can find directly I1. How can you find I1? I1 will be equal to the current, which is total current is coming I, okay, into the resistance which is opposite to this branch, right? The current you are finding for R1, okay, through this branch, but you have to take the resistance R2 and sum of the resistance R1 plus R2. So in case of voltage, the same resistance you have to take, but in case of current, you have to be careful. And I2 will be equal to I times R1 by R1 plus R2, right? So these are the voltage division and current division rules, okay, which, okay, so we can take one example here. Suppose there are two, suppose that this is 5K and this is 5K resistance, and there is a voltage source, okay, which is connected here. You can say 8 volt, right? So somebody will ask you that what is the voltage across this V1? What is the voltage across this V2? So you can say that V1 is going to be, as we know that these two resistances are same, right? So you can say the equal voltage will be divided, right? So you can say 8 volt into 5 upon 10. So this will be equal to, 4 volt. And also V2 you can determine like 8 times 5 upon 10. So again 4 volt, right? By inspection, you can say if two resistances are same, so voltage will be equally divided, right? And I can take the current also here. So current will be divided. If suppose two resistances are there, they are same, right? Suppose this is 2K and this is 2K, right? And this is 8 ampere. So you can say directly that current will be here 4 ampere and current will be here 4 ampere, right? Because two resistances are same. Okay. I believe this is fine for everyone. So guys, here you can directly say 4, right? So this is what the basic thing, right? You must know. Okay. And one more thing I would like to talk about is the dependent current source, right? Or dependent voltage source. Okay. So dependent sources. Okay. And you will be surprised that my first topic will be based on this only, dependent sources. And dependent sources will be used, to model the amplifier. Okay. We will use dependent sources to model any kind of amplifier, right? Whatever kind of amplifier we will study, we will try to model amplifier using dependent sources. I think everyone might be familiar, okay, about this, right? So dependent sources are of four kind, okay. So because as we know that in electrical engineering there are voltage and current, right? Okay. Suppose we have got the voltage source and a current. Okay, suppose this is how we represent, you know the voltage and a current, right? I mean the voltage source or a current source. So diamond shape we will be using, right? So if I put here plus minus, so you have to make sure that this is voltage source, right? This is voltage source, okay? And across this, if you try to measure the voltage, that is V out, you can say. So if this is a voltage source and there is a constant K times V in, right? So you see here, this quantity which is associated with this voltage source is a controlled quantity. What we call it? Controlled. Okay, voltage. Okay, voltage controlled we call it, and this plus minus sign indicates that this is a voltage source. So what is the meaning of this? The meaning of this is basically we call it voltage controlled voltage source. Okay, so why we are calling it voltage source? Because there is a plus minus, right? And this is a controlling parameter or controlled parameter, which is V in, right? So V in is here, right? So voltage controlled voltage source, right? So this is one type of controlled source, right? And you can say here is that suppose you have got plus minus here, and this time some constant k is there, right? It has some dimension here, right? So you can find the dimension of this k also here. As you know, v out is k times v in, right? You write here v out equal to k times of v in. So what is the dimension here? K times k equal to v out by v in, right? So this is basically the ratio of voltages, means it does not have any dimension, right? So in analog circuit, we will call them as voltage gain, right? Voltage gain, right? So for the moment, just I'm making you familiar with control sources. When we will start the amplifier modeling, the very first topic, so you will come to know, okay? And this is k times of I in you call, right? Again, you are trying to find the voltage across this, right? So this is a voltage source, and this is a current which is controlled, right? So what will be the name of this circuit? This element. This will be called as uh, you know current controlled voltage source, right? Current controlled voltage source. So here you see voltage controlled voltage source, here you see current controlled voltage source. And one more thing you can say here is that suppose there is a diamond shape, right? In some of the books, sometimes circle and there is a arrow also, but they say that this is dependent one, right? So this is what the scenario, and this is I out, you can say, because current is always through the branch. Okay, so this k times of I in, right? So here you can say this is basically current control current source. And one more you can expect here is that suppose there is a current source and k times of v in, but you're trying to measure I out, right? So what is I out here? I out here is k times of V in, and here I out is basically the k times of I in, right? So you can determine the dimension of k here again, which is the ratio of current, okay, which is dimensionless, okay. And here also you can see I out upon V in, means this is the k where the k has a dimension which is transconductance or conductance, you can say, right? Because I by v is a conductance, but we are calling it trans because we are focusing on output and input, right? So two different parameters, okay, belonging from different port, okay. So I out upon I in, okay. So these are the four dependent sources we will study. So current control current source, and this is basically the voltage controlled current source. Why we are calling it current source? Because there is an arrow. There is an arrow, right? So four kind of current sources, four kind of dependent sources, or you call it controlled sources. We will study. Okay. So in that you can say there will be four kind of amplifier also, right? Because there are four. After all, we are going to make use of these dependent sources. So there will be four kind of amplifier, right? So how quickly you can remember this them is like you can say this is the star and controlled source, and there is a source, right? So these star can take either voltage or you can say current, right? So now you can write here is that voltage control voltage source, current control current source, or you can say voltage controlled current source, or you can say current control voltage source, right? So these are the four kind of sources which we will be studying. Okay, okay. And these are very very important. So if they are present in the circuit, okay, if they will be present in the circuit, so you have to be careful while determining the resistance, okay, this rth, right? Rth, okay, because these are the voltage sources, you can't replace them with the help of we can't we cannot replace them with open circuit or short circuit, right? Remember this, we can't replace them, okay, the until the control parameter is zero. See, if control parameter is zero, suppose this current I in is zero, then you can replace it by open circuit, okay, then you can replace it by open circuit. But if this is not zero, okay, if this voltage is not zero, okay, so you can't replace this current source by open circuit, right? In case of this also, suppose V in is there. Let me take one scenario here. Suppose suppose this is a circuit here, right? And this is V in, okay, simple circuit, and there is a voltage source again, right? Okay, so this is k times of V in, right? And somebody will ask you what is V out here, right? Suppose, okay. So you can say that this V in is zero here, right? This V in is zero because it is the short circuit, right? Then you can say this is also short circuit, right? You can replace it by short circuit, okay? Then V out will be equal to zero, okay? Remember this. Huh? While suppose you are trying to find RTH, okay, and these dependent sources are present. If the controlling parameter is not zero, many students make mistake, okay, so you don't have to. And suppose there is a current, okay, you can say this I in, okay, and there is a current source which is, you can say, k times of I in, right? And you have to find the I out. So, okay, by default, you can say that this I in, because there is an open circuit, right? If there is an open circuit, means this will be zero. So this will be zero. Means you can replace it by open circuit, right? Because I in is zero, then you can replace it by open circuit, right? So this kind of a thing you will face, okay? In fact, in MOSFET, okay, in MOSFET, like there will be three terminal, okay, and this will be the SiO2 layer, right? So always we will consider that this gate current is always zero, okay. So this is the input current which is always zero. So this kind of model, okay, so we will try to model a different kind of amplifier using the control sources, okay. So these are the basic things you should know, right, before I get started the the analog circuit. And one more thing, there are there are different useful theorems, right? There are different useful theorem, okay, so you have to understand, but these are the basic theorems. One more thing is there, passivity, right? Passivity, right? Suppose this is the resistance, okay, and this current is flowing I. So how can we put the polarity of this voltage, right? So if current is entering any passive element, remember always, we call that is passive sign convention. What? Passive sign convention. So remember always this so passive sign convention, whenever any current is flowing, suppose they haven't mentioned the sign, okay, sign across this element. So whenever current is flowing, so always this current will enter through positive terminal, that is V. Okay, so you have to take always plus here, right? So current should enter. Okay, so this is known as passive sign convention. Suppose in the exam they have mentioned like this, okay, minus V plus, okay, and this is R and this is I. So don't hamper, okay, don't change this polarity according to passive sign convention, because in the gate examination, those professor have put these kind of polarity. So you have to accept this. Suppose nothing is mentioned, right? Suppose these are the two resistances which are connected in series, okay, and there is a voltage connected, right, like this V. So if you are, suppose this current is flowing through this, okay, so you have to take this polarity, right? So this current will flow from here, so you have to take plus minus, right? V1 and V2, okay, according to passive sign convention, right? According to passive sign convention. And what is the meaning of passivity? Passivity meaning here is that the power, right? The if this current is entering through this positive terminal, right? So you say that the power will be absorbed, right? Power will be absorbed, okay, absorbed, and the power absorbed will be always positive in this case, right? and the delivered power you can say will be negative. Okay, so these are the thing we have to take care of. Okay, many students get confused, right? And you will study different kind of theorems. So I told you the Thevenin theorem, right? That is the workhorse. Okay, Thevenin's theorem. Thevenin theorem, you can say practically is the practical voltage source only, because there will be one voltage source, right? Entire network will be looked at as the voltage source, and one voltage source VTS and RTS like this. And you will also come to know about superposition, right? Superposition theorem. So depending upon the situation, right? Depending upon the situation, right? So superposition we can apply it. We will use in fact while solving analog circuit problem. Okay. So there will be number of voltage sources or current sources. So we will activate one at a time, right? And then we will try to find the response. And at the end we will add all of them, right? So some superposition is very simple, right? So finding response because of individual sources and adding them up, right? Okay. We'll also talk about reciprocity theorem. Reciprocity. The reciprocal of that Thevenin theorem, you will also come to know about Norton's theorem, right? Or you can say practical current source, right? That is IN, Norton current, and there will be RN. Okay, so IN is basically IN will be considered as short circuit current, and this is IN. Okay, reciprocity theorem. I will give you the proof of this theorem also, right? And if time shall permit, right? Because you have to cover these things in network theory. And one very important theorem will be that Milliman's theorem, right? Okay, Milliman's. So these are the few theorems which you have to understand. And to prove reciprocity theorem, we will talk about diligence theorem. Okay. Intelligence theorem basically tells about the conservation of power. Okay, that's it. So there are many theorems which you have to study. These are the few which I have listed. Okay, which I will be using while solving the problem. Okay. So where Milliman's theorem will be used? Okay, we have to identify the situations, right? Suppose we will be given this kind of a situation, right? Suppose V1 is there, R1 is there, right? And many voltage source. Okay, different voltage sources are connected and in parallel, right? Like this R2, sorry, R2, this is R3, right? This is V3, okay, like this, V4. And suppose there is a load resistance RL is connected, right? And they are asking you to find IL, right? So this kind of circuit you can solve using KVL also, sorry, KCL also, right? You can apply one node because there is only one node is there, right? Single node is there, right? You can apply. But this kind of question you can do using Milliman's theorem, right? So whenever this kind of situation you will find, right? So you can directly find the, you can replace entire, you can view from there, right? You can view from there. So you can replace this with the help of one voltage source and one resistance, R dash and V dash, right? And then again you connect RL here and you can find IL. So this V dash will be equal to very simple way of finding this V dash. V dash will be equal to V1 G1 plus V2 G2 plus V3 G3 plus V4 G4, right? What is G4 here? G4, G1 is basically the reciprocal of this resistance, which is, so you can convert them into, conductance, right? So V1, G1, V2, G2, okay. And then you can also write here, okay. After all, these are the conductance, right? So we can divide also sum of all the conductances, okay. So in one line by inspection, you can determine this V dash, and R dash also you can determine just by finding the conductance, right? Adding them. Okay. So these are the things which we'll be using. We will be using, okay, for rapid calculations. Okay. Yes. And we will start with amplifier modeling, right? And thank you so much for today.